So, on to the part 2, testing iOS application. And this is ironically called breaking the taboos because, testing is a taboo because no one does it, no one admits that he doesn't, and no one wants to speak to anyone that he doesn't. So the obligatory, pre-talk poll if you want. Who supports an application on the App Store right now? Hands, please. 1, 2, 3. Okay. Who tests this application that is on the App Store? One semi-app hand. Okay. What this talk is about, and this is our agenda. A high level, an overview of what is testing and why you should do it. Configuring Xcode and the whole workstation for testing. We'll see an overview of what's the current state of testing frameworks, open source testing frameworks that you can use, whether you're doing Objective-C or Swift. We will speak about Nimble, which is actually a mature framework, Swifty mature framework, and I really like it and I use it and I will explain it to you. We will also talk about Okay, we'll talk about exit test, which is the default kind of testing framework that Xcode finally ships with, because back in the days with Xcode 4 and etc. You didn't have a native testing framework with Xcode integration, so you might have an excuse of not doing your tests back then. We will talk about testing view controllers, which is really important, because view controllers is actually what your user sees at your application. We will see some pitfalls and some bad practices that you might come across while you're doing your tests. And we'll talk about some issues that we might see at the future meetup here. Okay, first of all, what is testing? Well, tests are obviously code, and this code actually runs, or if you want, utilizes your current app's code with the utter goal of making sure it behaves properly. And one might ask, so what the hell is properly? Well, taking into consideration that the academic term for an algorithm is something that takes input and produces output, tests actually test that your code behaves properly in the form of taking specific input and always giving you the same output, as well as when stuff goes wrong and you give him fuzzy input or illegit input, it behaves properly and it doesn't crash to hell. There are lots of, actually not lots, there are kind of 5 type of tests, and I'm gonna list them here ordered by magnitude if you want. So unit tests are the smallest possible kind of test. They test one method and that's all, okay? One level higher we have integration tests, which might test more than one methods at the same time, or even a whole module, or even 2 or 3 modules together, okay? We have, of course, user interface tests that basically operate on the presentation level of your application and actually perform in an automated way what a user might perform on the application. And we have performance tests that might fully stress test your application by calling several methods and several intents functionality many times in order to see how they perform in terms of CPU, memory, and time constraints. So as you might have already understood, unit tests are cheap. They run fast. They test kind of small ranges of code, and performance tests, because you utilize as much of your application as possible, they are quite expensive. So why you should consider testing, and especially if you're doing gigs for a client, or especially if you care about your application and your reviews on the App Store. First of all, testing forces you to write better code, because you will see that when you start testing, you will come along some of your current code that there's no apparent way for you to test it. So if you start by writing your tests early, it will put you along a track that will force you to write cleaner and more compact code, so it will be more easily testable. Of course, tests ensure that you ship less crapware to your clients. There are significantly less bugs and less, crashing situations because you supposedly test everything. Your technical debt diminishes, and this is something that your CDO technical manager might like very much. Of course, if you have a certain level of code coverage in your current code base, it allows you to further progress with implementing new features with confidence, because you're sure that whatever you have written right now just works, and I can safely go ahead and write new stuff without having to worry about something breaking up. And regressions is basically the same thing. It means that if you discover a bug and you go ahead and write a test for it, you make sure that it will never happen again. That's a regression. Okay. So compulsory academic references. Tests should be first. We are engineers, we like acronyms. Here's another one. First. What first is that your test should be, first of all, fast. That means if you have a test suite that takes like 5 hours to complete, you will not run it as frequently as you should. So some bugs or some problems might actually get shipped. Your tests should also be isolated. And essentially, what does that mean? What that means is that your tests shouldn't depend on state that was created by previous tests. So, for example, if you're writing tests for a cache manager and you want to see if there's something in the cache, you need to make sure that prior to any test running, you should clear the cache, right? Okay, your tests should be repeatable, which essentially means that even if you run them 10,000 times, you will get consistently the same output as long as your original source code wasn't changed. So for example, if you have written some tests and although you haven't touched anything in your original code and 10% of the time some tests fail, you have a problem. Self-verifying actually means that your test actually asserts something, which means that they actually test the result of something instead of arbitrarily calling code. I have read some anecdotal blog posts about companies outsourcing the burden of testing their software to another company, and the other company went back and said, okay, we have 100% code coverage, which means that their tests were actually calling all of their code, but most of them weren't asserting anything. And they just saw this 100% number and said, oh, hooray, we have tests. No. And timely essentially means that you should write your tests as soon as possible, and even better before you go ahead and write your actual code. And this is actually called test-driven development. It's a practice that you might like it, you might not. But it is a good idea because it again forces you to think of how to write better testable code, and testable code, besides being testable, is also more compact and more easier to understand. So what I'm gonna do is I'm gonna take you hand by hand, by the hand, so you have absolutely no excuses whatsoever from now on to start testing your applications. So Xcode is kind enough to include a testing target by default. So please make sure that you check this button if you want, testing coverage in your application. Checking that button essentially means two things. You get a testing target, which is this one, and this one, and you get a testing bundle, okay? Now, if you currently have a project and you've been naive enough not to test it, you can still do it. Don't worry, it's very easy. You actually navigate to your test navigator. You click that little sign icon down here, which in my opinion should be a really big red button. And you click new unit test target, and boom, you get the information which target to be tested, and you get again the testing bundle and the new testing target. Now you have the most primitive setup to start testing your code. What do you need to know next? It's nice to know because testing, what happens is actually it builds your application like it would be in a normal situation. It lifts the whole stack, which means it lifts the simulator, and then it starts performing tests in an automated manner. And because you want your test to be fast, like we said before, there are some occasions that you want to know whether your application is being run in testing environment or is being run in production. And actually, in order to know this, there are 4 ways. The first way is to know that you're in testing in compile time in the form of preprocessor macros. And the other 3 ways, please. And the other 3 ways is in runtime. The first way is with launch time arguments. We will see what is this. Processing for environment, and the Objective-C runtime, which is also shared in Swift. Okay, the first one, in compile time, what do you need to do? You navigate to your project structure, okay? Here, make sure you're in Info tab, and you go ahead and duplicate the debug configuration, okay? This is, you've probably done it before. And what you want to do is filter here with pre-pro or preprocessor macro if you want to write the whole thing. And you click here and add this testing equals 1, okay? Simple. And then in your application did finish launching or pretty much anywhere else, you could have a preprocessor macro that says if not testing, do this and if. And why this is useful? For example, if you're testing, you might not want to include cross-lytics. You might not want to log as heavily as before, and other stuff. Runtime. You press Command and less than on your keyboard. You go to Edit Scheme. You go to your testing target. Okay. You deselect this little checkbox and add this is testing argument or whatever you want to call it. And then boom, in the runtime, you can create this method and say return ns_process_info arguments contains is testing, which means if I got this argument during launch, I'm in testing environment. Of course, you can declare it in your app delegate or wherever you want to declare your global helpers, and just use it here and there to distinguish whether you're testing or not. Now, you can also do it during the runtime by using the process info environment, because like I told you before, when you include tests in your project, you get a bundle, right? So this bundle gets injected in your stack when you fire up the simulator into testing mode. And again, by using process info environment xc inject bundle, you can check whether you're in testing mode or not. Finally, this is a runtime hack, and actually it's only applicable if you're using XC test framework on Xcode. And what it does is that when you're running testing mode, the XC test case gets injected in the runtime. So if you call this method and see that it's injected, it means you're in testing mode. Simple, right? Okay. Now, testing frameworks, there are quite a few. Essentially, they come in 2 flavors. Actually, they're not flavors, they're categories. You have BDD and TDD frameworks, which are actually how you write the specs. And you have the matchers, which is actually how you assert that something is equal to something or something is not equal to something. So in terms of BDD and TDD, you have XEUnit, which is the default of Xcode. You have Specta, quite significant contributors in this project, Facebook guys, GitHub guys. You have Kiwi, which is, I mean, lots of people are using it. Specta and Kiwi are quite similar, in fact. You have Cedar, which is another one from Pivotal Labs, I guess. And you have Quick, which is also maintained by a Facebook guy, and it's actually a pure Swift testing framework, one of the very few, and quite possibly one of the most mature. Now, in terms of matchers, please. Again, you have XEUnit because it comes with its own assertion macros. You have Expecta, which is, if you want, the sibling of Specta. It's written by the same guys. You also have Nimble, which I'm quite fond of. It's again purely Swift. And now, how do you come to choose a testing framework, right? First of all, in order to choose your this BDD means behavioral-driven development, and TDD means test-driven development. The difference between the two is that in BDD you write your expectations kind of like in natural language. So you say describe my view controller. It should create a pop-up when I click this button, and then you assert this test. Okay. So what you want from these frameworks is, first of all, you want to have good Xcode integration, which means you want to hit Command T, and you want Xcode to bring up the whole stack utilizing that framework and having the reports ready for you and all that, candy. One thing you might also want to consider is how close is this framework, the specking of the framework to your requirements. So you might be part of a big ass corporation that have a separate quality assurance test, or your CEO might be the one who does the quality assurance. And BDD helps because the CEO writes the specking, like we said before, in natural language, whilst on test-driven development he has to write functions and classes and some classes and stuff. You might also want to have mocking and stubby support. We're gonna talk about what mocking and stubby is probably in some of the next meetups. And from matchers, what you want is to have a convenient domain-specific language, because what these guys have done is that they have taken the bare bones XEUnit assertion macros and transformed them into natural syntax that you will see in a while. This is very important. You want your matcher to have asynchronous expectations. So, you might have an asynchronous expectation when you make a call to your backend and you expect a result, and you need to test this in an asynchronous manner. So your matcher needs to support this. What I like as per January of this year is bare bones XEUnit for BDD, for TDD actually, and the Nibble matcher framework, which is the sibling of Quick. And I like them because, first of all, XEUnit is the native thing. It has the greatest Xcode integration. Its harness is very flexible and bare bones. You can do whatever you want to have without having any constraints. It kind of looks fast so far, so I have about, it should be around 200 right now, and they usually run below 15 seconds. And Nimble, as you will see in a while, has great built-in functions and very, very expressive DSL, domain-specific language. So, Nimble, the fundamentals. How Nimble works, it has three parts, right? So you have the actual value that you want to test. This comes first, and you express this in code with the expect function, okay? And then you have the operator, which you chain to the expect function, and usually this operation is to, not to not, and there are some others. And then you assert that the value, the value that you're expecting is the one that you expect it to be. I know that doesn't make very much sense, but you will see in a while what I mean. So you would have like expect my var to not equal scatter, or expect my flag to be true. So you kind of have this thing going on. So you can expect values to be equal with something, expect values to be less than something, expect a button to be an instance of UI button, expect a string to be a kind of string, expect flag to be true, expect my array to contain Coco, expect my URL to contain HTTP, expect my URL to end with .io, expect my array to have count 10. So you use this domain-specific language in your testing functions, and if, for example, something doesn't pass the assertion, so if this flag is false, the test fails and you get a notification in your console. Of course, you can use the normal operators, so you can actually say expect actual equals expected, expect actual less than expected, etc. It's quite simple actually. And if you want to go further, it has support for C primitives, so CF string and that kind of APIs. It supports lazily computed values, it has async expectations, although they don't work very well. It has error handling, assertions for throwing, what Dimitris described earlier. You can write your own matchers, which is quite convenient to have complicated stuff going on. And you can have custom failure messages, if that helps you to log some variable or something. You can read the manual on the GitHub repository that they maintain. And now onwards to exit test. So what we saw earlier is Nimble, which is the matcher, and now we are going to see exit test, which is the native TDD framework of Xcode. This is the generic structure of a test. So first of all, using the testable keyword, you import your whole application into the testing suite as a module. Your testing suite starts by subclassing XCC test case. So whatever is in this class are your test cases. Each test case has a setup and a tear down function. The setup function gets called every time before every one of the testing cases, and the tear down is called after each of the testing cases. Okay. Now, whatever function you have declared in this subclass and that starts with test, it's actually a test case. So the XCD test framework, runs during tests. Of course, you could have helper functions that do not start with tests, so you can conveniently use them to manipulate data structures or whatever. So a very simple example with XCC test and Nimble combined. We have imported our application as a module into our testing suite. We declare in the higher level of our scope a variable named calc, which is actually off top my calc, whatever that means. We initialize it in setup, which means that it gets initialized, it gets a fresh instance before each test case. In tear down, we make sure we clear the cache, whatever that means, just to bring it in the neutral state, because like we said earlier, we want your test to be isolated. And this is actually a test case, which says, take this helper function, which is not part of the test case because it doesn't start with test, generate two numbers, and then expect the add function of calc, to actually add the numbers properly. Okay, very convenient shortcuts. It's good to know them. Command U executes all the test cases in your suite. Control Alt Command U runs all the cases in the current file that you have open. and command 5 opens up the test navigator, so you get all your test cases and a check if they pass or an X if they fail. Now, you might be kind of the console guy and you might like to run your test from your console. There are two very convenient tools. One is actually a tool developed by Facebook. It actually is a wrapper for Xcode's cell commands, and it pretty prints all the results, and it can also run your tests in a very easy and convenient way. You can install XC2 using brew, and Scan, which is a very interesting tool, and it's part of Fastlane, which is a very interesting suite of tools, and hopefully we're gonna have a meetup covering most of these tools. Again, it's just a command. You can skip this whole thing. It will derive your current scheme and your testing target, run your test, and give you pretty output and all that jazz. Of course, with Xcode 7 and something and beyond, we also have testing coverage data, which means that every time Xcode runs your test, it produces a report that says how much of your code is covered by your tests, and precisely which parts were called, which methods were called, and in order to enable you go to your testing target and make sure you click the gather coverage data. And if you do this and you run your tests, you will see that in your main editor, you get these red things right here, which says this part of the code was never tested. And for example, there's a 4 here which says this part of the code was regressed 4 times during your testing. Okay. Of course, if you go to the report section of Xcode after you have run your testing suite, you get a fully fledged report of what actions were tested during the test process, how much of your application has been tested, which functions and to what percentage have been tested, and all that useful information. Please don't fall in the trap of writing bullshit just to fill this bar, okay? Make sure you actually assert something, and make sure you always remember that silly company that outsourced the testing thing and got shit back. Now, testing view controllers. Very important because, like I said before, view controllers is what your user end up seeing when they run your application. So you really need to nail them. They need to be solid. You have to test the crap out of them. Most people think that it is impossible, but it's only impossible if you make those big ass fat view controllers that we all used to do. So you have this view controller that has a collection view and maybe a table view, and you have all the data source and delegate methods in the same file, which is in the view controller. Please don't do that. It really helps if they're pretty thin and you decouple delegation and data source to other files. Whoops. Okay, so many people might want to counter argue why would you want to test your view controllers whilst the cool guys from Apple gave us this new UI testing tool. The reason is that the UI testing tool is slow, because like the simple testing process, it has to bring up the whole stack, and then what it actually does is like having a robot clicking on stuff on the simulator and kind of simulating what you want to do. But it is definitely a good start because they are easy. I mean, you open Xcode, hit record, and then do stuff on your simulator, and you get automatically generated code that you can kind of edit and tinker with and just bring it to where you want. But they are super slow, and you could always do it the bare bones way, which is faster and more versatile. Yeah, so we talked about that. In terms of the testing categories, I would say that testing view controllers kind of falls into the integrated-ish tests. So they are not unit tests, they're not performance tests, they're somewhere in between. because they combine both, simple compact methods of the unit test and greater modules and delegates and data sources of collections. You should also make sure that you test whatever dependency they have, as soon as it's your dependency and not an external library. We're gonna see this in the pitfalls in a few. So how do you do it? What do we need, right, to test a view controller? First of all, view controllers have life cycle, and this life cycle begins with view read load. So you already know that most of the bootstrapping and initialization of your view controllers takes part in that view read load part, right? Occasionally you want the whole stack, which essentially means a window, so you can push and pop view controllers and test storyboards, logic, or whatever. You need to be able to reference IP outlets and treat them as a user would. And you usually want a way to detect state and hierarchy in your view controller. And by state I mean, did another view controller got pushed, or did a UAlert controller got popped, whatever. So one by one, triggering view read load, boom, very easy. The only thing you have to do is access vc.view. So you initialize your view controller in a variable. This underscore here means that I don't care what this is because I'm never going to use it, and the compiler doesn't, doesn't bitch about it. So what this simple thing does is that it actually triggers view read load, which is awesome because all the bootstrapping code that you have gets run. Unfortunately, no lag for view did appear or will appear, or did hide or will hide. So bummer. So what if you need a stack, or if you want to load stuff from your storyboards, or you need the basic foundation of pushing and popping stuff from your view controllers? We have a case with a storyboard here, so you initialize your storyboard in some variable. Okay, you instantiate view controller with identifier, that thing that you have registered on interface builder. You get a reference to the delegate, because what the delegate has is it has always a window, right? And the window is the most primitive thing that you need in order to display UI to the user. So essentially, this is the stack that you need in order to perform, push and popping of view controllers and other stuff. And so what you do is you initialize this window, you set a root view controller to this, in this case a navigation controller, and you make sure that you call make invisible. Okay, and then by using the same trick as before, you essentially have now the whole stack that you can use in order to test what we talked before about pushing and popping view controllers or detecting state. This is very useful because view controllers have most of the time some outlets, and most of the time these outlets are buttons, and when you tap those buttons, something happens. Of course, the naive way would be, in your test case, you would just go ahead and call the selector, call the selector of the button, but this doesn't ensure that actually the IP outlet is connected with an IP action, right? So what you want to do instead is, of course, assert that the IP outlet, in this case logout button, is of type UI button, and then by using this nifty little method, send actions for control events that's tapped inside, is like saying I'm a ghost and I want you to tap this as if I was the user. And this is also ensures, like we said before, that the IP outlet is actually hooked to an IP action. Of course, IP outlets are most of the time public properties of the view controllers, so you can easily access them in your test cases. Now, when you want to test hierarchy, right? And by hierarchy, I mean if a new view controller got pushed, probably as a result of an action, or if a UAlert controller or a pop-up, got displayed again as a result of an action. So, up until here, we've talked about this is the whole stack. This is triggering view did load. We use this nifty method to call the selector of the IB action of the IB outlet, and let's assume that the action is to present an alert controller, and then we assert that expect VC presented view controller. So okay, I started with that view controller. What is presented right now? This property holds this to be an instance of UAlert controller. Okay. Hello. Now, some pretty obvious, well, they're not obvious, but they are established bad practices. There is a tendency to write tests that kind of fall right here in the middle. So they are not unit tests, which is good to have. They are not integration tests either. So there are these dirty little hybrids that, test more than they should and less than they should. So don't do it. Another bad practice is giving your test cases shitty names. And it's a bad practice because the names of the functions that you give to your test cases are what is getting dumped in your console when a test fails, right? So for example, if this dog instance didn't have brown color, you would get test color failed. And good luck knowing what the hell this is if you have 500 test cases. So this is bad, and you should give ultra descriptive names to your test cases. So test German Shepherd dog breed has proper color, or even test German Shepherd dog breed has brown color if condition. It's not bad to have this, okay? You need to be explicit. Another bad practice is feeling the urge to kind of test private methods. And I mean, private means private, right? First of all, you cannot access them from your test cases. And for that reason, you kind of have the urge to change them from private methods to public methods in order to just being able to test them. This is utterly wrong, and if you feel the need to test the private method, it means that this private method is doing a lot more than it should be. So it's not a helper method to your to the rest of the API, but it's rather something dinosaurs, as we would say. So what you should do about it? The first thing that should come to your mind is refactor it. Okay, if a private method is not compacted doing just one thing, you might need to rethink the way that you want to write this logic in your module. Actually, the best way to test private methods is to do it through the public API of your class, because essentially that assumes that the public API kind of utilizes the private method the other way, so it gets called in one way or another. And if you have such a big dinosaur row that you cannot do any workarounds, you might want to dump it in a static class, create a very strict contract of what other classes should be able to use that static class, and test it that way. Most people that haven't have much experience with tests, including me, at least until recently, have this tendency to couple their tests with implementation details of their code. And this is bad for lots of reasons that, I mean, it could be a one-hour discussion, but you should at least keep in mind these 3 bullet points, which first of all is never in your module test, so you're testing a module of your own, you should never call APIs of external libraries. So that means that if you're using Alamofire in a module and you want to do that request, you don't want to directly call Alamofire, okay? Because if you go ahead and change this library, you know, down the road, then you have twice the work of refactoring work to change your tests back and, you know, work around this. So one possible solution here is to just stub it, okay? Which brings us to the second bullet point, and you know, mocking and stubbing is okay, but always make sure that you test the external libraries independently in another test case. By the way, I think Alamofire and Matt Thompson is kind enough to have his own tests into the pod. So yeah. And constructors are also implementation details, and they shouldn't have, and normally don't have, any behavior. I mean, if you have logic and behavior in your constructors, this is a smell, and you should probably refactor it. I guess that'd be all with bad practices. Going further, if you want to explore more things around testing, you can check out stubbing and mocking objects. And what that means is, instead of using the actual instance of, let's say, NS user defaults or NS notification center, you create a fake class that has all the helper and the sugar that you want, and you just feed it to your code and use that instead of the actual one. And stubbing could also mean stubbing network requests. So instead of directly making an HTTP call to your backend, you just create a stub, you get a predetermined response without any networking stack being used, and you continue with your testing logic, having that response already handy and available. And after a while, you might start exploring stuff around continuous deployment, which essentially means that you do not run your tests on your own, but you have a mechanism that kind of plugs on the repository, and whenever you do a commit or a pull request, it automatically runs your tests, and even deploy the application to test flight or facilities, or even deploy the application, if it's tagged as a release, to the App Store. This is very interesting. I guess we could have a talk about it. And that'd be all. Questions? Anything? This is Ventura. Pretty good guy. So any questions about testing? Anything you might want to, you know, any objections?
You said about UI testing, that is slow. Does it do the test in real time? It just clicks like a user would do?
More or less, yes.
Launches the app, starts it up, is using the accessibility API, so it takes as long as you take the user to navigate it out.
What kind of tests you tell it to do, and what kind of results we expect?
So for example, so before that thing, there was an instrument that was called UI recording, okay? So what it would do is, it would fire up the simulator and say, click whenever you want. And you would click, you know, in text field, you would type your login, you would click another, you would type your password, and then you would click, you know, login, and then you would get another screen, okay? And this would get translated in kind of something between if AppleScript fucked JavaScript and had a baby, something like that. But then they figure out this is an accessibility hack, so you get native Swift code, but it's still as low as kind of having an ultra-fast robot doing the tapping. So it's not it's faster than the previous thing, but slower than having bare bones explicit test cases, like we talked. Okay, please test your applications.